Math 1314, Tyler Junior College, Section 2.7, Inverse Functions. Finding the inverse of a function. So far, we've defined an inverse function, we've shown how to verify the two functions are inverse functions, we've answered the question, how do I know if you have an inverse? But the one question we haven't answered is, if you do have an inverse, what is it? So this video and the next one will discover and illustrate how to find the inverse of a function once you know it has an inverse. Now, if you are asked to find the inverse of a function, you can usually assume that it does have an inverse, but this question could be phrased, does this function have an inverse? If so, find it. So let's first verify that it does have an inverse. In the previous video, we discussed three techniques for verifying whether a function has an inverse or not. One is algebraically, to show that it's a one-to-one function. We won't do that. Another is to show that the graph is continuous and either strictly increasing or decreasing. We could do that. The third is the horizontal line test, and we will do that. But to do that, we need the graph of this. Recall that the graph of f of x equals x cubed, f of x equals the cube root of x, is a sideways cubic. So it looks like this. And recall that this transformation to the function, minus 7 on the x, invokes a physical transformation to the graph. Specifically, if you subtract a number from the x, it moves the graph to the right. So we would have to move this graph to the right 7 to get the graph of that function. So instead of crossing at the origin, it would cross over here at 7. And we can ask one of two things. Is this graph continuous? Yes. And continually increasing or decreasing? Yes. It's a slow increase, but it does. Or we could break out a horizontal line and see if we can hit it twice. We can't. No matter where I move this horizontal line, I can only hit it once. So all the evidence says, yes, I do have an inverse, supported by the fact that I'm asking you to find it. So how do you find the inverse of a function? Well, the trick to finding an inverse of a function goes all the way back to the very first thing I said in the first video about the inverse of a relation. Remember that a relation is a set of ordered pairs. So pair of something, pair of something, pair of something. And to form the inverse relation, we take that ordered pair and reverse it. So the catalyst for this is to reverse the x and the y. Now there is currently no y in here, which is why the first step for finding the inverse of a function is to change f of x to y. So this is a purely cosmetic move. We're going to write y equals the cube root of x minus 7. And now we can pull off the move that creates the inverse relation, which is to switch the ordered pairs, and we achieve that by switching the x and the y. So your second move is to switch, if I can spell, switch x and y. Meaning, everywhere there's an x, you put a y, and everywhere there's a y, you put an x. So we get x equals the cube root of y minus 7. Now, what we've basically done is buried the dependent variable y inside the function. We're going to dig it out by solving for it. And when we solve for the y, on the other side, we will be building our inverse function. So your third step is to solve for y. Now, how easy or difficult this is depends upon the caliber of the function. This one's not too bad because we only have two things we have to undo. We have to undo the cube root and we have to undo the minus 7. Which one do we undo first? Well, think about how you would do this problem if you substituted a number. You would subtract 7, then you would cube root. When you undo it, you have to undo it in reverse. So the first thing I must undo is the cube root. And to get rid of a cube root, you raise both sides of the equation to the third power, which will give us an x to the third power on the left. And on the right, the cube and cube root cancel, leaving y minus 7. And now it's easy to solve. Just add 7 to both sides. So x to the third power plus 7 is equal to y. At this juncture, you practically have your inverse function, but we should actually state that we have the inverse function. So we're going to change y to f inverse of x. In fact, now would be a good time to draw a conclusion. Here comes that 3-dot triangle that means the word therefore. Therefore, f inverse of x is equal to x to the third power plus 7. There's no need to substitute it and check. There's no need to check domains and ranges. I promise you, they are inverses. So if a function has an inverse, these are the 4 steps you take to solve it. Change f of x to y, switch the x and the y, solve for y, and change the y to f inverse of x. All 4 steps involve y in some capacity. In the next video, we'll take another look at an invertible function, which is going to be a little bit trickier to find its inverse.